It's me, Mr. Pleasant Person, presenting some draft physics um, for your consideration. If you can do that, can you consider things in some sort of reasonable manner? That's the question. So, anyway, we only have one comment, but it's a subject, got lots of pits in it, we can use. So I can certainly make an hour out of it. You know, yeah. Well, let's get to it. Okay, now Einstein blew all that up, right? None of it is true in their Einstein world. So I'm talking about the fact that electrons are moving and there's a force between them, and all of this idea that all motion is some sort of a relative thing and that there's no absolute motion in the universe, that things don't move in any absolute way, and that space doesn't have an absolute structure, that the geometry of the universe doesn't bend and warp and stretch and do all this stuff they claim it does. And that in the small universe, that just doesn't work. Distances have to be reliable because all of these things are very reliable, and you can't be stretching and warping space all over the place because none of the stuff on the small scale, the tolerances just don't provide you that option. Okay, so so that's why I said what I said. Is because, oh, wait a minute, I'm talking about the small universe, and you really can't apply Einstein's rules to the small universe. Anyway, then why don't you accept the idea that the speed of light is constant? I do accept the idea that the speed of light is constant. That is, light, photons, capture distance, travel distance at a set time, and it never changes no matter what kind of stupid notion you have about being in any kind of frame. Okay, so I'm the one arguing that the speed of light is constant. Einstein's arguing for something different, like somehow the speed of light only exists as we perceive it. I mean, it's almost as bad as their whole quantum crap, where they start speculating about the fact that no event takes place unless there's a consciousness around to see it. This has nothing to do with what you perceive. It has to do with what we can physically know happens. So, like two people on a bus throwing a baseball back and forth, they perceive that they're throwing a ball at a certain speed. They have a perception of what they added to the ball. But we can physically know that their motion in a direction was also added to the ball. It's moving with the bus, with them, and that it has a velocity already built into it in a direction. Okay, and so when they throw it this way, they're not really throwing it this way, they're throwing it that way. Okay? And it's just a fact, and we know that. That's the real physics. We know that the ball has a velocity, okay, and that you're going to add another velocity to that velocity, and you're not going to be creating a new velocity in a naked circumstance. The circumstance has an initial condition. Now, you want to talk about initial conditions? I might accept that better than I can accept inertial frame, okay? But the real point is I think we can also know that photons don't do that. Photons don't care if you're moving the flashlight, okay, this way when you emit the photons. And Einstein knew that. Photons just couldn't care less how much you move the flashlight. The photon isn't going to come out in some new direction. No, it's going to travel the direction you throw it, and that's it. It won't have any extra based on your motion. It doesn't combine velocities. It has one velocity in one absolute space, and that's it. And one direction it'll move in, and that's it. It can't combine momentums, where a baseball, we know, physically does. Okay, as the baseball's moving in the bus, we're going to add a velocity. Okay, and the two are going to be added in the real world. The velocity this way is going to be added to the velocity this way, and you're going to get a velocity that way. Photons don't do that. You're asserting they do. That's the difference, fundamentally. That's where we disagree. Now, you say you have some pile of evidence that photons do carry multiple momentums, that they can combine different momentums, that if I do move the flashlight, the photons do come out crooked. That's your argument. So let's understand what the argument is about. Okay. The light is constant in any inertial frame. I don't accept that inertial frames have any relevance to anything in physics except human perception. Okay, that the only thing broken in frames is perception, not fact, not actuality, perception. So when we're talking about this idea of two spontaneous events, okay, happen, and I change my position, and so I hear one. So there's two nuclear bombs. One goes off in Japan and one goes off in whatever, someplace else, that way. I happen to be closer to the one in Japan. So the two bombs went off at the same time. Just because I'm closer to the one in Japan, that one blows me up first. Even though they were spontaneous, they were, synchronistic. What's the word for same time? Well, anyway, they happen at the same time. I hear one first. Does that mean the one wasn't the same time as this one? No. It just has to do with my perception, the fact that I'm not going to perceive it correctly because of my position, period, in space. That's all. That's the only explanation. That's all the explanation we need. Our perception is wrong, plainly. There is no fact that, because I'm standing closer to the one in Japan, it actually happened sooner. It's not a fact. It doesn't break the fact that there's time out there that has a reality, and that what I'm perceiving is irrelevant, frankly, as fact. It isn't how you decide what the facts are. It's just to say, which one did I hear first? That's not how you decide what the facts are. So, again, and this is all in the context of the tiny, meager evidence they have for any of their assertions. And they're just basically saying, shut up. We've decided what the truth is in this circumstance. So they're going to assert to me that the events weren't simultaneous because they heard one first because of their position closer to it. And they're going to tell me that somehow they've changed the physical fact that they are simultaneous. That somehow that frame gets to decide when the event happened. And that frame has nothing to do with when the event happened. Doesn't decide it. Your position in space does not decide what happens in space. You have to deal with just the physical reality that light takes time to travel to places, and you're not going to see something happening for a while sometimes. But that's it. It didn't change when it happened. All right. Maybe that can be the solution to the drag issue in your theory. Again, why? Why would it be the solution to drag to say observers are controlling the universe? No, I don't think so. That doesn't fix anything. Okay. And also, time dilation was predicted by SR for the first time. I'm not confident. Well, good, because frankly, like I said, lots of novels were written before Einstein, okay? Even the famous one, The Time Machine, right? And it implies speed. It clearly implies that his little wheelie clock machine is hurling through space at a speed to change time. So clearly there's lots of conversation about the fact that the speed of light was the decider of time ultimately, and that somehow if you could go beyond the speed of light, that you could go beyond the clicks of the clock and break time. I want to hear your opinion on this one. I don't know if you really do, but I've been over it, so you certainly could have found some of the videos on the subject. My argument to you is you have no theory of how photons are even produced. No theory. You just say it happens. Comes out of atoms somehow. Electrons somehow are involved. You have a vague notion of how the thing is created in the first place. And yet you make these confident assertions based on, again, tiny bits of evidence. I mean, the evidence that you break clocks, that is, even atomic clocks can be broken by speed, shouldn't pause you. I mean, in the sense that you should recognize that, well, what evidence do I have that I can't break any clock? So yeah, I'll give you an example I thought of. All right, so I'll throw it in here. So, Einstein did these thought experiments. Well, okay, here's a thought experiment. I mean, sort of, demonstrate something. So let's say you're going to play this game of flashlight. You're going to move through space at a faster and faster speed and shoot photons forward out of a flashlight. And your people are basically arguing that you won't allow me to go at the speed of light. Somehow you have a rule that the thought experiment doesn't allow that. But if I actually went the speed of light, would you concede that no light comes out of the flashlight, right? And the real argument is that, well, what happens, like I said, if I'm going almost just 99.999% of the speed of light, the argument really is that Einstein's basically saying that, well, you'll be so time dilated, okay, that 1 second in the real universe, okay, 1 second in the real universe, that is, the universe time has to live in. Time lives in the real universe. Light, I mean. So light doesn't get to do your frame crap. And the idea would be is that you'll be going almost the speed of the light, and that this time that it would take the light to move the distance of 1 second, which is, going around the Earth 8 times, I think. Anyway, that distance, you would perceive that distance, you would cover that distance perceptually, okay? Let's see, I'm probably saying this the wrong way, but regardless, this would be essentially 1 billion years for you, right? So 1 billion years of your perception will you'll be so slow, you'll be perceiving 1 billion years of these seconds, okay, happening, while 1 second happens for the photon. Okay, so then the light will be coming out so slowly, I mean, relative to your speed. The photon will be gaining on you so slowly. So you're moving, and the photon is moving just a tiny bit faster. So it takes so long for there to be the actual 1 second of distance. Takes so long. So 1 billion years. You have to sit here for 1 billion years waiting to see and then you open your eyes. So it's like you blink, and the blink takes 1 billion years, and then when you open your eye, oh, the photon's right where it's supposed to be. It's gotten away from me. But it's going to take 1 billion years for that to happen. And that'll be the actual fact. So you're actually saying that I will be so time dilated, my functions will be so frozen, and you're basing it on this calculation that atomic clocks are disturbed when they're accelerated, moved. And so that's what it's all based on, is how much an atomic clock is disturbed. But my argument to you is that no, nothing really changes, right? I mean, the photon still comes out of the flashlight, and the fact is that, yes, it doesn't come out of the flashlight is moving the same speed as the photon, so there's no chance of almost the same speed, and so the photon will in fact take a very, very long time in the history of the universe. The universe will be spiraling around, galaxies will blow up, all this stuff that can happen in 1 billion years will happen while you're waiting for the photon to get a little bit further ahead. Okay, a few Earths diameter, circumferences, distance, a tiny fraction of the distance between the Earth and the Sun, for the photon to travel that distance in terms of gaining on the flashlight, the universe will actually have to go through 1 billion years of its life. It's probably 1 million, but doesn't really, it's a preposterously long period of time it would take for the flashlight to get far enough away from the photon it just shot. So, but that's the physical reality. And we're not talking about any perceptual crap. The physical reality is if I took the flashlight in space and I didn't have no people involved, and the flashlight is moving almost as fast, okay, as the speed of light, and the photon pops out, the fact is the whole universe, okay, will go through a billion years of time before that photon is 8 circumferences away, okay, from the flashlight. And that's the physical reality. And this has nothing to do with all this perceptual crap. It's irrelevant what a frickin' observer is observing. The only thing that's relevant is what's the physics. All right, and the physical fact is that you, theoretically, if we could make a physical thing go as fast as the speed of light, that it could be shot at the same time as a photon, and it could sit there and just watch the photon going, and I'm going, and the photon's going, and I'm going. And you're just playing some game that time changes. Well, time doesn't change. The object perceiving changes. You're just arguing that physical bodies are changed by the process of motion. But the universe didn't change. The universe is swirling. All this crap is happening in the universe. There's no evidence that time changed anywhere. That there's some bubble that you're in, that I'm a time bubble. No, you're a broken clock. All right, so the other illustration would be this blue. So what if you took a time clock, right? So let's say we could make the perfect time clock, which would be you put a photon in, okay, and it just bounces back and forth. Okay, so there's no emitter. So you just capture a photon between two perfect mirrors, and the photon just bounces back and forth, right? So that's the principle. Photon goes here, hits the other mirror, bounces back. That's it. That's a time clock. Same distance, and the photon just bounces back and forth. Now, your theory, or my theory, let's just say I would argue what's going to happen is if you move these two surfaces, and that's what we're going to do, we're going to move them faster and faster. And what's going to be the consequence? Well, first off, it's not going to be any Lorentz bullshit, right? It's not going to be some dopey crap that there's no time dilation until you get over here, and then all of a sudden there's a huge amount, right? So there's nothing, there's a flat line. This is basically the R squared picture, right? I mean, so if you chart gravity, gravity has like an opposite chart, it's like this, where you get a lot of change in the strength of the gravity, and then the change gets imperceptibly smaller and smaller as you go further. As distance gets greater, the amount of change in gravity gets infinitesimally small. But there's no reason to think light has anything to do with the inverse square law. The inverse square law is made out of the fact that there's change in two dimensions. The things are going further apart, right? This way and this way. That's the inverse square law. There's, it's getting bigger in two dimensions. There's no reason to think that time is two-dimensional. So this is another pile of assumption that you just say, why is that assumption there? Because if I did this light clock experiment, you could sort of understand that what's going to happen is this surface is going to move just as much as this surface, right? So the photon is in between. And let's say we have perfect reflections, right? Well, what's going to happen if I move it? Well, if the photon's going this way, well, I'm moving the thing it's going to bounce off of. So it would have hit it here, but now it has to wait and go all this extra distance. But the same thing's going to happen on the return trip, right? Except the opposite. So on the return trip, it's going to expect to hit the surface here, and instead the surface is going to be here. So whatever it lost here, the thing moving away from it, the front surface moving away, it's going to gain because the back surface is also moving towards it. So it's going to have to go less distance this way. So it has to go more distance this way, but it has to go less distance this way. And the two will add up to exactly the same amount of distance in theory. So no matter how fast I move it, the actual time it'll take the photon to go from one surface to the other surface to make a complete cycle will always be the same, because the one surface left just as fast as the other surface is catching up to him. So he's always going to travel the same amount of distance no matter how fast I move the light clock. right? But then you could argue that if I move the light clock, if I'm moving these surfaces without having enough distance between the two surfaces, right? So you have these two surfaces, but at the speed of light, you're moving them so far, okay, that it's longer than the distance that you were timing, right? So the amount of time it took to hit one surface to the other, the distance you were traveling, is, unfortunately, you're now moving it so fast that the surface is moving faster than the cycle time of the light. And so now the clock won't be broken because the light has to do this, I was over here, you're moving that over there. It's more distance than this distance. So you've moved more distance than it can do in a second. You've moved it more distance in the same amount of time. And so it can't do the cycle. The cycle gets broken. So anyway, you can break the light clock, but if you make the distance long enough to start with, so you make it 1 billion light years back and forth, you're not going to break that clock until you're going really, really fast. But anyway, so I'm just saying you could do a thought experiment. Just say, okay, what's your theory? How are you saying it's something other than that? That somehow something other than that happens? That the light clock is a perfectly good way to see what the actual time is. And this light clock won't do any Lorenz bullshit. Okay, I mean, it won't do all the time breaking here. If it was to do any, it would do it in a perfectly linear way, I mean, the chart would just be a nice, you have time dilation here, you have it here, you have it here, you have it here, you have it here. There's no mechanism for all of it piled up at the one end. So I'm saying there's huge holes in your theory that you don't have to answer, right? You just make your assertions and you never answer any of the assertions, my counter arguments. You just ignore all of them. Or certainly ignore the ones you have no clue how to answer. All right. And that's a flaw in this way of communication. Is you have all the power to ignore, because I can't re-ask the question and re-ask the question and re-ask the question. You'll just ignore it. All right. So he starts off okay, and the next guy gets snarky, but the other guy was more snarky. All right, so superior mind, let's just say we have some common understanding, and so we'll just take his remarks as his own, not mine, because they really aren't mine. I'm not DraftScience, there you go. But I'd say light travels at a constant speed in an absolute coordinate system. Yes, that the universe is an absolute place, and the absolute rules of physics apply to the entire universe. And you can't create frames where you say something else is happening, where something like time is different. Time won't be different. You can break clocks, but you can't change time. All right. And that is why time dilation happens for objects of higher velocity. Well, I'm just saying time dilation in quotes. So obviously I would say is perception distortion happens with velocity. The wrench traveling through space that I throw into space is physically different than the wrench you don't throw into space. And if you might be able to find that out is after 1 billion years of travel, the one wrench molecularly might be less corroded. It might be less something. And you could say, oh, look, there's a difference. Well, there's a difference because movement means the atoms are different. I mean, it really comes down to, do you understand that protons and electrons are the things that have to move? That they are where the movement starts? That you just don't move whole atoms in space and not change anything in the atom? That the little bits inside the atom have to, through their charge, through their connection to each other, through attraction and repulsion, that whole system has to be moved. And it has to be moved by the electrons and the protons moving. The atom doesn't move, the bits inside do. My hand doesn't move, the bits inside of it do. I mean, that's the fact of it. Okay, you can pretend that whole objects move, but they can't move unless their electrons and protons are forced to move. Something has to motivate them. Something has to drag them along, push them along. You have to hit the proton and then change its position, and then the electron will change its position relative to the proton. You have to change the whole system. You have to drag it along. And you can see how delicate that is in the sense of the solar system, because if you jerk the sun around, the solar system would fall apart. So clearly gravity wouldn't work as a mechanism holding anything together, because it just can't take much jiggling. A tiny bit of change in the position of the Earth in its orbit, and it shoots out of the solar system or crashes into the sun. I don't know how many millimeters it is. I don't know what the exact calculation is about how much latitude we have in our orbit, but it doesn't take much of a change in our orbit, and we're spiraling out or we're spiraling in. And the same is true of the sun. I change its position a little bit, a couple of diameters, maybe a lot less than that, and everything in the universe starts flying on all kinds of wrong directions. So obviously gravity wouldn't be a system that could tolerate much movement or much force. But again, what do you think's moving? How do you think atoms move? Can they move without moving the electrons and the protons? I mean, what's your argument? How do you think the universe works? Anyway, let's see. Also, there is drag for electrons and protons in real life. It's an important subject. I don't know if anybody can assert it for a certainty yet, but I'm just saying it's clear. What's the alternative explanation? We see it. Okay, it's a real pain in the ass in the sense that drag means that the electric bill at the LHC is really, really high. It's because of drag. Okay, because they have to overcome that. They have to pump in more and more energy to get more and more speed. All right, anyway, I'm guessing that the neutrons are the essential component to fix the drag problem for objects in motion. Clearly, it seems that that's the thing. The system can overcome what the elements can't. So you can arrange them in a way where one's the blocker, let's say, and the other one gets a free ride behind it, and that they herky-jerky into each other or something, some mechanism that allows the drag to only affect one of them. So it's almost like race cars, right? They overcome drag by doing drafting, right? So one car has to fight the real wind, the real universe, and the other car slips in behind and cheats and writes, and so he loses. The car behind the one car, so you have two cars, one gets really close to the first car, and he has 20-30% more engine efficiency. Now he's behind a car, which sucks, but he can save gas, he can save tire wear, he can save a lot of stuff because he doesn't have to fight the real universe anymore. The real racetrack, and then he can just pop out and use his his extra, right? He still has extra engine left, where the other guy's working as hard as he can. This guy still has some extra engine, and he can slip out and pass him. Not because his car is better, but because his car has conserved its energy by not having to face the real world. To use an analogy. So yeah, there's a physical mechanism. The cars themselves independently can't overcome drag, right? But working in some pattern, the drag problem is mitigated. And that's what we actually see. That's what the evidence indicates. You can't throw the electrons at the moon. You can't throw the protons at the moon. But if you put an electron and a proton together into a little helium nucleus, you can throw that to the moon. That's the catch, right? It's obvious. It's there right in front of us as a fact. So do you have an argument to say how that's not a fact? Then go ahead, present your argument. The complex thing is able to survive. And you can almost argue that this can go to muons, because they say, muons are this, and this. I would argue that muons really are is a collection of something. Okay, that's what they have to be to survive. And now you're just talking about how fast you destroy that system. How much can that system tolerate? But anyway, let's move on. Drag for electrons and protons in real life. I'm guessing that the neutrons are the essential component to fix the drag problem for objects in motion. Right. That's how it appears. You need the neutron. If it doesn't have a neutron, you can't throw it. So if you have a wrench that don't have neutrons in it, you ain't going to throw it. Protons and electrons as independent objects can't do it. They have to work together, and that's essentially what a neutron is. I could guess that at one moment the blue would have more velocity and shield the red, causing the red to catch up as the blue is slowed down, causing them to cross, so the red has more velocity as the blue then lags behind, causing the red to be dragging while the deficit of force for the blue causes it to accelerate again, and it cycles perpetually that way. Yeah, so he's basically just making an argument that the things are in motion, and there is a conservation of drag in the object behind, and so he's not dragging as much, so the system as a net system has less drag, you could argue. But the fact is, it's essentially you got to create a motor. You're going up the stream, and the fact is that real matter can be made to have little motors in it that just keep pushing it against the drag. All right. Cause it to perpetuate. Okay. It actually does look like neutron formations, purple overlaps. I don't know if you need to get into that, but yes, they're dipoles. Do usually retain more velocity and less randomness in simulation. Whatever. Yeah, who knows yet? The only way I could see a true inertial frame for light working, the only way I can see it working, is you have to have this assumption that somehow photons are baseballs, and that if I have an inertial velocity with my photon, when I shoot my photon like a baseball, it still has its mass as a moving object in a direction, and it will combine the motions. It will combine the velocities. And I'm just saying, I think there's a ton of evidence that photons don't do that. That if I move the flashlight, the photons won't come out in the wrong direction. Who is moving versus... Okay, so let's see. Velocities otherwise. Where was I? Light working is for each admission there to exist a copy for every possible relative velocity. Okay, the only way I could see a true inertial frame for light working is if for each admission there exists a copy for every possible relative velocity. Otherwise, unsolvable paradoxes would form, like light traveling away and towards observers who is moving versus external measurement of the same thing. Well, the consequence of pretending that time has something to do with anything other than how far light travels in a second, and that's always consistent in any frame, it's just a fact, and that you can have arguments about perception, but perception is irrelevant to the physics. So the fact that you think you can time travel or you can go into cryogenics, and that's what would happen to you. See, the light clock will break. If I move the light clock, the surfaces, if I move the surfaces more distance than the distance of the clock, right? So I've moved it so far that the light has to travel more distance. I break the clock. So I'm just saying you can break clocks, but you can't change the physics. You can't change the physical fact that light always, no matter where it is moving the same speed. Now, Einstein implied that. Einstein implied that the emitter and the receiver are irrelevant. The photon does its thing. Photons are independent of their source. It doesn't care which way the source is moving. The photon is essentially something released into the world, and it has an completely independent momentum. It's not like a torpedo being shot off a boat. It's not like any of those things, in the sense that you don't have to account for your speed in any way whatsoever. The photon has one momentum in one direction, and it just can't do multiple momentums. All right. And so like light traveling away and towards observers who is moving versus external measurement of the same thing. In which case, for the measurement to be the same within the inertial frame, the light would need to slow down relative to the outside observer when moving opposite direction of the velocity toward a moving observer. Yeah, well, getting into these things in thought experiments, I mean, those are really things you do have to draw. What you're saying, but again, all the paradoxes that are created by this idea of even the twin scenario and all this stuff, if nothing actually moves, then how can you tell which twin is moving and then which twin is getting older? I mean, the whole thing just breaks down and becomes incomprehensible. In summary, this all seems quite a bit more complex, yes, and unlikely, and apparently others have pointed out the potentially flawed assumptions in the math before too. It's certainly, you hate to say it's complex because you're working with something so simple, the speed of light and the traveling of distance. And so that shouldn't be a problem. But perception is the real problem because there's this assumption that no matter what speed I move my eyeballs are going to see the same way they see when they're not moving. And I guess the argument I'm clearly making is clearly they won't work that way. And clearly, if all of these thought experiments, you just put windows, on the spaceship, you just make the rest of the universe viewable, you're not going to have any problem knowing whether you're moving or the universe is moving, in the sense that you can make the assumption the whole universe can't be doing the moving, because that would have consequences to the rest of the universe, and their radios wouldn't work, and all kinds of things would be broken. And it's yours that are broken, so you're moving. But anyway, I would argue the light clock tells you your speed. So if you turn the light clock, horizontal to your motion, and just watch it going back and forth, you'll see your speed, because the light will hit surfaces lower on surfaces, because you're moving the surfaces perpendicular to the motion of the light, and obviously the light can't hit the surface it would have hit because you moved the surface. But anyway, all right. So this was a stupid comment, so we'll read it. Look, Supermind's comment is useful, but I mean it requires you to use a lot of your personal Blackboard space to follow along. All right, no point in wading through such dense fallacy-laden gibberish. Now, I might argue that, okay, you got some gibberish in there, you got a lot of complex ideas thrown into one paragraph. You can make some complaints, but fallacy, how have you demonstrated anything to be a fallacy? You have no description of how a photon is created. You don't have any idea whatsoever, right? I mean, you won't tell me how photons are created, right? Like, where's it? You won't show me its birth process. How does a photon get birthed? What is a photon? Is it a ray length? What is it? Can you draw me a picture that isn't some kind of nonsense where you just make a wavy line and say that's a photon? Is it this long? Is it this long? How many of the lumps are in a photon? You don't have a description of a photon. You have nothing. As Einstein said 2 years before he died, I haven't advanced my knowledge in 50 years. And the truth is, the human race hasn't advanced its knowledge in 200 years, 300 years, since Newton. It hasn't gained anything. It pretends it learned something, right? I mean, 120 years after Newton, Young shows up and says, look what I saw, a two-slit experiment. Well, Newton had already done the experiment. I mean, it's not news. We already know that light does diffraction and that there's this pattern. So Newton's rings, it was already described as Newton's rings. The two-slit experiment is just taking a clip out of the rings, just a segment. No big surprise. But yet we think we advanced our knowledge. What knowledge did you advance? What information did you gain? Nothing. So you really haven't gotten anywhere. You've said, let's call it wave-particle duality, and we're pretending it's both things, but you're not learning anything. Anyway, so you know what a fallacy is on the subject of photons, because you have such a clear view. You have such a clear description of how they function that you can sit there and say there was something completely and obviously wrong, fallacious, something trivially wrong, in the sense that it's such a trivial truth that you can't possibly get it wrong. It's such a fundamental crime against logic. There's something fundamentally logically wrong. Now, you won't tell us what any of those wrongnesses are, because you don't have any model. You have nothing. You just have your silly assertions based on scant, little tiny glimmers of a piece of evidence. Okay, because Einstein predicted something that somebody else might have predicted, that yes, when you move an object, you've imposed force on it, it is changed by the motion. The molecules inside of it, and the atoms, and most importantly, the electrons and the protons have changed their position relative to each other. They're in a different configuration when you move it. Okay, now somebody might have said that 200 or 300 years ago. Who knows? I'm guessing that motion does change objects. And so that somehow changes their function. Their metabolism has changed. What's going to happen to them over time will change. And you've converted that into this whole time dilation theory. So you have no evidence that if I accelerate a human being to half the speed of light, which still by the Lorentz transformation won't give you much dilation, but let's say I do it, that somehow you really think you're going to age slower. That you think that's going to be the effect, because that's an effect on one object, that'll be the effect on all objects, is to somehow have a consistent metabolism change or something. And again, we don't have any evidence that it's all that consistent. I mean, Einstein's theory, okay, even for stuff like the GPS, the numbers are fudgy. You know, they're really not that, there's no like perfect math that comes up with perfect answers. So the dilation, the change in time, isn't some exact thing. It's a very inexact thing. And they have to tweak it to make it, you know, they just do it by what works better. You know, they adjust the clock the amount that works. They don't adjust it strictly by the mathematics. So anyway, let's play along some more. All right, fallacy-laden gibberish. So we're not going to know what these fallacies are, and you know where he has certain knowledge of how photons are produced, certain knowledge that they carry two momentums. You know that they can incorporate more than one momentum. That somehow a photon is in fact not something already trapped. It's like a bird analogy, right? I could give you this bird analogy. A bird flies one speed all the time, like a little hummingbird. He always flies the same speed. And I put him in a cage, and he flies around at the same speed in the cage. Now I move the cage on a train or something. The bird's not going to give a shit. He's flying the same speed, right, all the time. So whether the train's going 500 miles an hour or 100 miles an hour, not going to change the fact the bird's going the same speed. So the fact is that he's going to be in this cage, and the cage is going to be moving. So when he's going this way with the train, it's going to take him a lot less time, a lot more time to get to the other side of the cage. So he's going to flap his wings, flap his wings, flap his wings, flap his wings, lots of time. But when he's going the opposite direction of the train, you know, the opposite direction of the motion, he has to one flap of his wings, and he's already to the other side of the cage. So all that's going to change is going to be like the Earth's orbit. You know, when you have an elliptical orbit, you go really fast down at the bottom, and you go really slow on the big part. So it's kind of ironic, right? You're going really fast on the short distance, and you're going really slow in the big distance. So it's like it's not an analogy to a bird, but it's an analogy to the fact that if you didn't allow the Earth to speed up or slow down, the fact is one is a longer distance. I guess the Earth is a counter. I mean, anyway, I shouldn't have used that example, because clearly the Earth does vary at speed, where I'm arguing the bird doesn't. But I'm just saying you can understand that when I open the cage, the bird's going to fly the same speed it got caught at, the same speed it always flew at, and it's going to leave the same speed in the same direction that it's always been flying. And it's the whole experience of being on a train isn't going to change anything at all. It's going to fly one vector at one speed, and it's not going to fly it based on the motion of the train. All right. So it all just has to do with how you understand what a photon is and what it's made of. I mean, I'm arguing that it's moving the same speed as all the other forces. All the other forces are made out of the same stuff, and a photon is just that stuff at a period. Now, how is that fallaciously laden gibberish? That's all we'd ask from you, right? You're going to say that's fallaciously laden gibberish. Well, how is that fallacious? How do you have obvious proof that that's wrong? All right, anyway. Let's see, but just to point this out, you're not going to point anything out. At 3240, he says that the spirals in cloud chambers are evidence of electrons coming to a halt from drag. Well, it's probably not very good evidence, because let's understand that the electrons are actually traveling through a medium. Okay, that's why we're seeing them. And we're only seeing them when they're going fast enough to create photons. So they're creating enough energy to break down other atoms and force them to release energy. So clearly that has part to do with their dragging to a halt in a cloud chamber. I'm just saying, if we do know that if I take this and I make this a sterile environment for the photon, I create a non-atmosphere environment, I still have to keep pushing it. You can surmise that the photon does the same thing, in the sense that the photon will not reach targets. All right, so the argument is that yes, the cloud chamber gives you evidence of what happens to electrons as they travel through space, but it's superficial in the sense that you have to account for the fact that it's going through a medium of ammonia or whatever the hell it is, and alcohol, and that that's part of what's degrading its motion, is it's creating photons, and to create photons you have to hit something, blah 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 blah. But it does show it, some percentage of that degrade is no doubt drag. But anyway, I probably shouldn't have used cloud chambers as an example. We just don't have any way to watch electrons in any other way but to force them to interact with something. So I'm just arguing that, but the evidence is clearly, I'm just saying the evidence is clear, all right, from colliders and atom smashing and all of that crap, that that we can't maintain them. Look, the evidence is clear from when you create the balanced magnetic field, and you shoot electrons through it, and they're spiraling. Okay, so you've got them caught in a trap, essentially. And that trap can be a really good vacuum. Now, most of them, they have to put a gas in so you can see the electrons again. You have to force the electrons to hit something, and we have to see the little sparkles that come off the light. But the truth is that if they don't put any gas in there, the electrons just don't stay. They don't keep going around and around and around. They lose their momentum. So you tell me why they do that. All right, anyway. Besides drag. Okay, here we go. Let's see, where else are we? He says that the spirals in the cloud chambers are evidence of electrons coming to a halt from drag. The problem is that it would imply that the Earth is stationary. There's no such implication. So he says it in capital letters as if he's going to provide evidence of how that reasoning makes any sense at all. The ability to detect the changes at the level of even photons, you have to use smaller things to see small things, and the amount of change that you're trying to detect is really tiny, because it does happen on the scale of the force moving. You're talking about changes in force, all right, to be able to see changes in motion, because that's what causes things to move, is the force buffer. So you're not going to see it with things as big as an electron anyway. But anyway, let's just play along. That this would imply that the Earth is stationary. It wouldn't. The electrons are spiraling in relative to the Earth. Well, yes, you could argue that there's motion. The cloud chamber is moving. Yeah, that's for sure. But the irony is that if you look at the spirals that happen, with electrons in cloud chambers, they're not perfect circles. They're eccentric, weird blobs of blah blah. Okay, they're really not symmetrical. Yeah, pause for a moment. And I'm back. Okay, so the problem is this would imply the Earth is stationary. No, it isn't. Because the electrons are spiraling in relative to the Earth. Yeah, so if his drag hypothesis were true, so this is how they're going to assert something. So they don't know what a photon is, yet they're going to make assertions about somebody else's explanation of what a photon is, and they're going to make it based on their own assumptions, not the rules of the people who actually tell you how photons are created. You'll ignore those rules and play this game. Cloud chambers could be used as speedometers, as electrons' loss of motion would be relative to the absolute coordinate system. Well, that would be true if we didn't already know that their motion is not straight. It's, in fact, and not nearly straight enough. So it's like the photon argument, right? So, I mean, theoretically, if we could actually shoot a laser beam to another point, okay, that we would be able to tell if there was a distance change in terms of where these things go relative to each other, the emitter, okay, and the receiver. There's going to be a time the photon's traveling. It's not connected to anything then, right, between the 2 points. So it's in free space. The objects are on the Earth. And so in the time when the photon was released, the Earth is in one position, and the argument is when the photon is going to be received, it's going to be in another position. So it's going to be somewhere different, theoretically. And we'd be able to tell. It'd be closer or it'd be further away. So in some way, it's going to be in some other position. And that's the whole problem. We can't tell whether it's going away. We can't tell how fast the solar system is moving. We can't tell how fast we're moving in the galaxy. We can't know any of those absolutely. So at any one moment, we don't know whether we're on this side of this side of the solar system or that side of the solar system. It's going to matter which way you're moving, of course, and which speeds are adding up and which ones aren't. So, we have a net velocity at any one moment. There's a net velocity for the object when it's here. It was going this way. By the time it gets to this other material object, the net velocity of the system, okay, the tugs, might be in that direction, in some completely different direction. But anyway, the point would be is that you could use this light clock. Well, the problem is, though, is that if you have any knowledge of the physics at all being argued, where the direction of the photon really depends on the position of the electron. So depending on where the electron is, it's going to come out in a different direction. Photons aren't emitted consistently. That's the whole point. So the point is we don't have a laser beam that isn't doing this. I'm exaggerating it. But the point is it's spreading with distance. And you're trying to detect this kind of difference in movement, this much distance, with something that's spreading, 4 or 5, 10 times more than the distance you're trying to measure. So that's kind of impossible, because there's not going to be any real center. There's not going to be anything you can detect as this is where the laser is pointing, because it's already diverged well beyond where you could see the change in where the spot is. The divergence is more than the distance the spot would be moved. And that's going to make this experiment impossible, practically. And that's with photons. Okay, the smallest thing. You're talking about a big giant electron that you shot into space. Clearly, the argument that electrons do have mixed motion, and that drag won't happen just in this direction. Drag's going to happen in this direction, and this direction, and this direction. The electrons move in all kinds of wacky ways, because it just depends on what forces hit it as it's traveling, and that's random. And so this isn't in any way a predictable line of distance, because it could have this many humps in it, or it could have, just because it, just lucky, there's only 4. And so this distance is going to be variable. The speed will never be a consistent speed, so to speak, relative to 2 positions in space. Relative to 2 positions in space, the electron isn't going one perfect speed, because it's not traveling one perfect path. So its speed, that is how much of this distance it's covering, will change depending on how eccentric its motion is in that particular segment of time. So all you can have is an average speed. You can never have the actual speed of an electron, and it'll never be a consistent speed. So clearly you can't be measuring how long it takes it to get from point A to point B when the randomness of the universe is going to be constantly changing that speed. Okay, so all you'll have is an average. You won't ever have an absolute speed. All right, probably enough on that. It'd be nice to be able to do these experiments. I'm just saying, LIGO has a nice 2.5 mile long tunnel. They should use it for this purpose. But the problem still is their laser is made for a particular purpose, which is again, they're shooting a ton of light, taking a tiny bit back that they claim is in phase. I mean, the other problem is getting the light in phase. Okay, and so he says, if the drag hypothesis is true, the cloud chamber could be used as speedometer. Well, you can't use electrons in tiny amount of space and make a calculation about relative movements. It has to be a big amount of distance. The bigger the distance, the more likely are you see the deflections. Anyway, as electron loss of motion would be relative to the absolute coordinate system, but we don't see that. So this is just such a straw man argument. We don't see something that wouldn't be possible anyway, and the experiment couldn't possibly work on the scale of distances that the electron's moving. The size of the spiral wouldn't be a big enough spiral to be able to detect the tiny thing you're trying to detect in the tiny amount of time. Anyway, Superior Mind parrots that also there is drag for electrons and protons in real life. I'm just saying that do you have some other hypothesis? I'm all ears. So why don't you explain to me why electrons in free space can't be shot to the moon? Do you have some hypothesis why they can't? We can't do that. We can't shoot electrons to the moon. You want to tell me why we can't do it? Where are they hitting in free space? What's stopping them? What's stopping them from just keeping going right to the moon? So you want to just tell me? Yeah, thanks. As a matter of fact, in face of reasoning evidence to the contrary. Well, where's the evidence to the contrary? Where's the evidence to the contrary? Where's your evidence that electrons we can give them perpetual motion. We can make them like a wrench. We can throw them into space and they'll just keep going. Where's your evidence of that happening anywhere? That's right, you have no evidence. Okay, how can someone have such little conceptual understanding? So is he responding to himself again? Something, I don't know. He needed more comment space. How can someone have such little conceptual understanding that he cites something that either implies the Earth is stationary or disputes his own BS? So he never stated that. So again, and where was your explanation of how the motion of an electron in a cloud chamber would prove the motion of the Earth? That you could detect that subtle change in time, right? Because the electron is still moving fairly fast. I don't even know if we can image the electron actually doing the spiral, right? We can only get a tiny glimpse of one moment in time. We can't really videotape it. Have you seen the videotape of the electron spiraling? I don't know. And again, that's because it's moving through a moving medium, right? It's not moving through space. It's moving in a medium that's already moving on the surface of the Earth, a medium full of alcohol and ammonia or whatever. So, a little bit of thought, you can say, okay, I understand that you can't use that as an experiment to detect motion. And so we were back to the laser beam argument. The only really good thing to use is light if you can. But the argument is that we can't control how light is emitted yet very well. I would argue that you'd need to make the substance that's producing the light very, very cold, and the substance receiving the light very, very cold, because this all has to do about the position and the condition of the electrons that are emitting the light. And if you concede that electrons are involved in that process, and the more variation you can take out of the electron's motion, the more hope you have of doing the experiment. But that's what it's going to require. And you want to pretend that no, it's been proven it doesn't work, because, and I'm going to make the argument that there's no way you can test it with the instrument you're using. You're saying I can make a radar speed gun out of this pen. I'll just point it at a car and it'll tell me how fast I'm going. And then you're saying, see, I proved that radar guns don't work because this pen can't be used as a radar gun. That's essentially what you're doing here. And then you're going to call somebody else fallacious. You're going to force me to defend radar guns, okay, by saying this is a radar gun and it doesn't work. Right? And that's not a fallacious argument. You holding up a pen saying this radar gun doesn't work. Yeah, of course it doesn't work. It can't work because it's not designed to work. You want an experiment to work, you have to design it. It has to be designed within the diagram of your experiment. Your light clock has to have mirrors far enough apart to tolerate the amount of motion you give it, or it's not going to work. It's not going to tell you what you want it to know. So you have to make it to fit the experiment. You can't use your thumbs to move microbes under the microscope. It just won't work. Can't physically do it. Doesn't mean microbes can't be moved because your thumbs can't move them. It just means you can't use your thumbs. It's physically not going to work as an experiment. It's not possible. Such assholes. I mean, jeez. We've proven it with no proof, okay, realistically, except them strawmanning the argument and forcing me to defend, the crayon, radar gun. Okay, so it looks like that's it. Maybe I'll just leave it there. I'll do a little bit on the simulation stuff because it's sort of interesting. It's been a very good process just going through it in terms of realizing that you can make subtle changes to this model, and maybe you can really get to the core of it all. So nothing there either. All right. So all you're looking for is a system that creates two different functions that are the same in the sense that their effect is opposite. Okay, so you have the same function, but it's creating two opposite effects. And you're just trying to find the simplest way to do that. So that's essentially what magnetism is. Something that appears to be identically the same, except somehow it's fundamentally different, right? I mean, the south end and the north end seem to be doing the same exact thing, yet what they're doing is completely inverse. They have the inverse effect on the universe around them. So we have the idea of the electron, and I'm arguing that, so if this green force, so there's two forces, all right, you kind of know that already by now, I would imagine, and there's two kinds of charged elements, electrons and protons. So the idea would be the green force can hit a blue thing, right? And I shouldn't have put this other green arrow this way. And so what's going to happen is the green arrow is in some way going to reflect. Now, is it a real reflection? My argument is what's really happening. So let's ignore the swimmer thing for the moment and just deal with the fact that what's in the blue thing, okay, is a bit of blue energy, all right, and it's going this way. And so if we understand that it's going this way and it hits, right, so green hits blue, we can understand that the green goes this way and the blue goes this way. So what's in this circle that we call an electron, we know we've reversed the energy, a piece of the energy. And we've reversed a piece of the energy going to the universe, in the sense that something that was going that way, like a photon, is now going the opposite way, right? And that matters because the photon has energy. It will move things, is the point that matters. And so the radiation, so let's change it slightly and just say, well, this thing that it hits could have some other momentum. It could have been going, I might as well just do it with my fingers. it could have been going, say, this way. All right, and so this hit this, and what really is going to happen is they're going to exchange, okay, their momentum. So now the blue thing is going to be going this way, okay, inside, and the green thing is going to leave this way. All right, so you could sort of understand that if I really did that, all of these directions are hittable except for this direction, right? So if I have an arrow in here already going this way, well, we know the green thing can't hit that because those are both birds and they're both flying the same speed. So it can't really have any realistically hope of hitting this. It'll never hit somebody moving away from it. So it can't hit that piece. So we know that the only dimensions it can hit are this and this and this. And then we know we have the other two dimensions that we're not going to play with right at the moment, but we have two more choices, you know, this way, that way, and towards me. Well, you know, obviously there's a huge, you know, what you call percentage bias of what you're going to hit. You're going to be a lot more likely to hit this, and, you know, than you're, and this. Well, this, and this, and you're not very likely to hit this in comparison, right? You got a 4-to-1 ratio of hitting something going this way versus hitting something going some other direction, and that includes all the directions, of course. So, but obviously this way is out of the question. You're not likely. Your likelihood of hitting anything going away from you is less and less likely. And the likelihood of hitting anything towards you is more and more likely, right? So the stuff moving towards you, you're more likely to hit than the stuff moving away from you. So when this reflection happens, you can clearly assume there's going to be a higher likelihood that the reflection happens on this face. That this face will be a lot brighter than this face. There won't be too many things reflecting off this way, and there'll be a lot of stuff reflecting this way. All right, so we got that one down. I think you should be able to have gotten that. So let's try the other scenario, which is now you have the blue energy coming into the blue object, and the idea here is that it's going to do the same kind of exchange thing, except the rule, okay, is that it transmits. It doesn't reflect. The exchange happens in a purer way, if I can say that. And the momentum change is going to be, they're going to exchange positions. So where these guys hit each other, okay, and reflected, this one's going to make the pure exchange. So what's going to happen is this guy's going to actually go in, and he's going to go this way. And whatever was moving, okay, is going to come out. Yeah. Right. Well, that's probably the same difference, right? All right, I have to think about it. Well, anyway, in the other drawing, it does come out like there you're going to get more energy going out this way. Okay, then you'll get energy coming back this way. I thought that's how it came out, but maybe it just comes out that you reflect more blue from one side, the same side again, but I'm not sure that's true. Well, anyway, either way, you can understand that there's going to be the mirror, so to speak, is going to reflect more energy back than it's going to reflect forward or transmit, and that differential means that, you know, when one's a mirror and one's a transmitter. Yeah, I guess I have to. I don't know where. Somewhere in there's a mistake. You know, it's little subtle details, but I mean, let me do this one more time. This comes in. This is going to be transmitted. Okay, so that's the difference. It doesn't make the exchange, and it's just going to be transmitted in the direction. It can't be transmitted in the direction. It's going to. So let's say if it hits something going this way, which is more likely. It's the same circumstance. So the thing leaving exchanges, and that would have to be going that way. Yeah, I don't know what I did wrong here, but I did something wrong. All right. Well, I'm probably not going to think of it. Well, I might think of it. Maybe I'll just pause and then I can think about it. Because clearly something in my thought process is incorrect. Back. I'm thinking, just don't do much thinking at 3 in the morning or something. I was just doing this as the replacement thing. You know, the idea is that if two things of the same color hit each other, you really can't tell that anything happened because one thing ends up going this way and one thing ends up going this way, and both missing and hitting ends up with the same thing. So the idea would be is this thing is going to, they're going to interact, but all you're going to be left with is one thing inside the boat that's going to go this way, and one thing will be leaving the boat going the same way as that one was going. You're not going to have a reflection. You don't make something bounce off of it in some new direction. So all you're going to do is have the two directions. Well, I shouldn't have put it this way because that's not the way it came in. But the idea would be is anything, the energy be coming in this way, especially if the object is moving towards it. And the idea would be is it would just go through it, so all the energy be coming out this way, because they're just going to switch places. Whatever you hit, you'll be going its way, but you're staying inside. So the thing that hits it stays in going the way the old thing was going. You took his direction, and the new thing, the thing you hit, is going your way, and so your way stays and his way stays. So no matter what you hit, the world stays the same in the sense that there'll be one thing going this way inside, even though it's a new thing, and there's one thing leaving. So the point is that these two circumstances would make energy going in this way come out this side, and energy going in this way comes out this side. So it's just the idea that you've created the two opposite effects depending on the color, and if you invert all this, it should work. In terms of you conserved all the angular momentum in both cases, but you have two results. One pushes force that way and one pushes force that way. So that's the important difference. All right. The simulation will speak for itself eventually. You know, all right, so enough of a video now. Yeah, so sorry for the less than perfect continuity of the ending. There is a video on this time dilation stuff that I should play, but I guess I want to do the whole video. That's a stupid video. It's worth saying, well, here's some more crap, because he has no clue how mirrors work. But again, making assertions of, again, how they've proven the quantum mechanical theory with some experiment that they don't cite, so you can't see where they did this proof, what the proof is made out of. But anyway, this is just such a hideous pile of crap. You know, just glorifying the Eddington experiment, which, you know, is known rubbish, and you know, just making these classical arguments that somehow, well, I shouldn't even get into it, but I mean, there's a part where they have this part where they keep saying the reason why there's no photons standing still is because of Einstein's theory. No, we don't see any photons standing still because we're not moving as fast as a photon anywhere. I mean, it's just such a bad argument. Oh, God. Insanely bad. But anyway. But in their relative world, I guess they would have this expectation that something must be moving the speed of light and it just doesn't know it, you know, because it's in a couple of double frames. But whatever. Until next time. I think there's been enough said. The point is, as always in all these videos, all these people telling us what is a fallacy and what's stupid and what's dumb and you're retarded, they're all saying it from a position where their evidence is incredibly weak. It's not Darwin's evolution at all. They don't have anything even close. Not even close. They don't have just even the geology argument or you know, even the experimental evidence, in the sense that Darwin was sort of proven, evolution is sort of proven just by the fact that we did unnatural selection. it's just logical to assume, well, we're selecting to make our dogs smaller and cuter and prettier and fluffier and all this other crap. We make, cabbages and whatnot. We've done our selecting to change wheat over time. I mean, clearly the process is just so obvious, and the concept of nature doing selection is just so obviously true, that left to its own devices, the selection process will be obviously the survival of the fittest thing, and fitness will just depend on crappy circumstances. 1 year fitness is going to be being tall, the next year short, fat, thin. I mean, it's always going to change, this definition of fitness. Well, anyway, it's just it's so little evidence you need to prove it. And they don't have anything like that. They have no underlying concept that just makes it all make sense. They got nothing. They got bent space and virtual photons. And here they are being so arrogant about what the truth is, when they can't even describe the two most obvious forces in the universe, gravity and magnetism. They have no clue. Nothing. Bent geodesic. Yeah, well, I know it's a geodesic in the sense I know the universe is made out of geometry. So yes, that part any idiot could figure out. Again, they're not telling you anything. Bent space doesn't describe anything we didn't already know. It's just telling you this is what the inverse square law looks like. Okay, if I made it out of fabric. That's all they're doing. They're just showing you the curved line. They're not showing you anything that means anything. They're not explaining why things travel that line. What motivates the electrons and protons to change their relationship to each other? No force required, essentially. So why are they looking for a force for magnetism? If we can move stuff for free, we don't need forces. Then why are they bothering even looking for a virtual photon? Why don't they just call it bent space? Bent space moves magnets into each other. Lumpy, mountain space and valley space. Because it sounds stupid, that's why they don't say it. But if they had any consistency, that's what they would argue. Anyway, till the next time and such.